Friends, welcome to my YouTube channel. Dhanesh here. Another session on machine learning. In the last video, we were discussing about different statistical tests, ANOVA test, t-test, z-test, even F-statistics we discussed. In this video, I am going to discuss about F distribution. Let's start. This is a very nice quote from Mother Teresa. There are no great things, only small things with great love. Happy are those. Let's continue. With F distribution. So in this video, my focus is on F distribution. See, F test is named after the great British statistician R.A. Fisher. F test is used to find out whether the two independent estimates of population variance differ significantly or not. In short, we can tell F test is used to find out the variation or what is the difference between two population variance. See, variance, it's an important term in statistics. You are familiar with variance. It's the square of the standard deviation. We have a separate video on variance in the playlist statistics. You can watch it. It is the square of the standard deviation. Standard deviation gives the spread of data or the scattering of data. Fine. F distribution is used to compare two population variances in hypothesis testing. This is the most simplest definition we can give for F distribution. Fine. This is the math of F test. This is for population. Sigma 1 square by sigma 2 square. You know sigma is the standard deviation. Sigma standard deviation. What is sigma square? Variance. The square of the standard deviation is variance. Sigma square is variance. You know it, variance. This is the equation for population. You need to understand the difference between population and sample. You can watch the previous videos. Basic concepts. These are all basic concepts in statistics. S1 square by S2 square. When you for a sample, you write the variance. It is denoted by S1 and sigma square. S square, sigma square for a population. Here you need to understand the variance. Sigma 1 square must be greater than the sigma 2 square, and S1 square should be greater than S2 square, because sigma 1 and sigma 2, why it is to compare the variance of two populations or two samples. Simple. This is the math of F test we discussed. Again, I am, these letters you are familiar. Sigma 1 square is the variance and sigma is the standard deviation. It's written here. And the equation for variance is sigma of, this is the summation, sigma x minus mu the whole square by n. This is for population and this is for sample. The second equation is for sample and this is for population. It is sigma of x minus x bar the whole square by n minus 1. Fine, simple. See, math of F test in generally the larger estimate of variance by smaller estimate of variance. That's what we discussed. Now let's consider, a random variable of size n1 for a normal population and sigma 1 for the standard deviation for that, n2 another population with a standard deviation of sigma 2. These are all the you understood. Sigma 1 standard deviation of population 1, S1 standard deviation of the sample drawn from population 1, sigma 2 the standard deviation of population 2, S2 the standard deviation of the sample drawn from the population 2. See, this is chi-square. You know the Greek letter. This is chi-1 square. This is the chi-square statistic. You are familiar with chi-square statistic. We have a separate video if you want, because I am giving you an equation in terms of chi-square as well. Chi-square statistic. as well. And in terms of degree of freedom, if you want to get more clarity on degree of freedom and chi-square statistic, you can, I know this is not statistic, you can watch those videos of chi-square statistic and degree of freedom. Degree of freedom is sample minus 1. That is the formula. Fine. See, and this is the v1 or new one. You will use new one as well. New one for the degree of freedom for the chi-square statistics, first chi-square statistics. Chi2 square is the the chi-square statistic for the sample drawn from population 2, and we do the degree of freedom for chi-square statistics 2. Degree of freedom is number of samples minus 1 and 2 minus 1. This is simple. I think you understood this. In terms of chi-square statistics as well, you can write the equation. Degree of freedom is sample minus 1. Simple equation. Then this is in terms of chi-square statistics and degree of freedom. The first equation we can write it as S1 square by sigma 1 square divided by the ratio S2 square by sigma 2 square. This can be written as chi-square statistics divided by psi 1 square divided by v1. V1 is the degree of freedom of the first sample and v2 is the degree of freedom. This is v2, or some people will use nu2. This is another letter for degree of freedom, or you can use v1 or nu1. Nu1 is another letter. Both the letters you can use, it's fine. So this equation is really important in terms of chi-square statistics. So this can be written as psi 1 square by nu 1 the whole divided by psi 2 square. This is psi, this is the Greek letter psi 2 square by nu 2. This is the math of F statistics in terms of chi-square statistics. There is a a nice video on chi-square statistics. You can watch that video for chi-square statistics as well. Fine, you understood. See, F statistics and null hypothesis, if you understand, calculate the F value, the calculated F value. You will calculate the F value if it is less than the tabulated value. Tabulated value means from you can get the F distribution table, and you can get the corresponding F value for the degree of freedom. If the calculated F value is less than the tabulated F value, the null hypothesis is accepted and there is no significant difference between the two variances. If the calculated F value, F calculated, is greater than the F tabulated from the distribution table, F distribution table, you will get one value. You will calculate one value by using the formula. Then that value is greater than the tabulated value. The null hypothesis is rejected and there is a significant difference between the two variances. F test is the ratio of two variants, hence it is known as variance ratio test as well. Fine. This is the F distribution curve. This is the way it looks like. See, normally the normal distribution is symmetrical about the mean, but this is not symmetrical. It starts from the origin and it goes to the maximum value, then it goes to infinity. This is like in math, if you are familiar, asymptotes, like it's parallel to the x-axis. The value here, it is 0, and in the x-axis we have taken the F value. This is F suffix alpha. Alpha, it is the significance level. Alpha, there is a separate video on significance level, and its optimum value is 0.05 or 5%. This is the optimum value for alpha, and this value, this is known as the F alpha. This is the optimum value. This area we will call it as the rejection area. This is our statistics, it don't work, and it is known as the rejection area. Alpha is equal to 1 minus C, another formula, it. It is C is the confidence level. C, it is known as the confidence level, alpha. See, this is, you understood from the graph, it's, the value of F starts from 0, it reaches the maximum, then decreases, and then it goes on. It's not meeting the x-axis, it goes to infinity. That's what. you understood. So this F alpha is for the corresponding significance level. See this area, this area, we always use the p value and the significance level. You know that. You try to understand. If you don't know those concepts about significance level and p value, you try to learn it. We have videos in the playlist statistics for p value and significance level. Okay, fine. See, significance level, I have given the equation 1 minus c, it's the confidence level. See, these are all very, very nice points I am giving to you. The characteristics of F distribution. F distribution always skewed to right. You can see it is always, sorry, it is always skewed to the right. If you see the distribution curve, it is skewed to the right. Fine. Value of f is always greater than 0. You can see it. It starts from 0 and it increases. It is, the minimum value is 0. So it's always greater than 0. The value of f is always greater than 0. The second characteristics. Shape of f distribution is determined by the degree of freedom of numerator and degree of freedom of denominator. Because degree of freedom, I have shown you. See, the equation I have rewritten in terms of, that's why I have written this equation. It depends on the degree of freedom. In this equation, we have written in terms of chi-square statistics. And, it's, you can see it as the degree of freedom is in the numerator and denominator, it's there. So the degree of freedom, it's an important term in terms of the F distribution, and the shape of F distribution is determined by the degree of freedom of numerator and degree of freedom of denominator. Range of F distribution is 0 to infinity. It starts from 0 and it's go on infinity. See, it reaches to infinity, 0 to infinity. It goes like this. It is not meeting the x-axis. That's what I am trying to say. If F distribution has a median value 1, see that I didn't tell you. See, it's so closely, its median value is 1. This is the median value, right? So this is 1. F distribution has a median value of 1. Fine. F distribution is not symmetrical. See, our normal distribution or Gaussian distribution, it's also known as Gaussian distribution or bell curve, it is symmetrical, all right, but our F distribution is not symmetrical. Another important point, this is a very nice point, as degree of freedom increases, the symmetry of F distribution increases. Actually, the F distribution is not symmetrical, but it tries to become more symmetrical as the degree of freedom of both numerator and denominator that's increases, the symmetry of F distribution also increases. That is, degree of skewness decreases and with increase in degree of freedom for numerator and denominator. You got the point? So that's what. See, the degree of skewness decreases with increase in degree of freedom. The symmetry of F distribution increases with degree of freedom. That means the degree of freedom is directly proportional to the symmetry and degree of skewness is inversely proportional to the degree of freedom. Degree of skewness is inversely proportional. That's all about F distribution. Thanks for watching. Please like, share and subscribe. Thanks a lot.